Hello everyone and welcome back to my channel. In this video, we will be working on data manipulation and analysis. Python indexing stands as a fundamental concept that empowers developers to interact with data stored in various data structures. Indexing acts as a key to unlock the power of accessing individual elements and extracting subsets of data effortlessly. Throughout this video, we will look into different examples related to indexing and how it is used to handle, filter, and analyze your data. Additionally, we will also explore various Python libraries in this video, such as NumPy and Pandas, and we will utilize this to perform our indexing in Python. So, let's get started. First, we are importing Pandas and NumPy libraries. So as soon as I import this library, we are good to go to the next stage. In the first example, we are creating a list of 5 elements and we are accessing elements through its indexes. If we use my list or print my list and in the brackets, square brackets, we pass 0 or 3, it will get the indexes and get the element on those position. So on 0 we have 10 and on 0, 1, 2, 3, at third we have 40. Moving on, we can also access the elements using negative numbers like -1, -2, -3. So -1 will start from the last element and then -2 and -3. So that's why -3 will output 30. In the next example, we have got a string and we will pass the same indexes, but this time it will print just a single character because it's present on that position. So on 0 we have H and on 7th index we have P for Python. Next we can do the same with negative indexes and it will print the last element first and moving on to -2, -3 and -6, and at -6 we have Y. Next we can slice or extract the substrings from a string. Like for example, we have this string and we can extract a substring using indexes. So we are defining to get the element from 0, starting from 0 till 5. uh, so the fifth index is not included, so 0, 1, 2, 3 and 4. So comma will not be here, so as you see comma is not there. And for Python we are saying it to start from 7 till end, so we didn't provide any indexes, so it will make sure that it covers all the characters after 7th index. So it print Python as well as exclamation mark. Next we have got a dictionary, and next we have defined a dictionary in which we will be extracting its value. So we have got key and value, key and value, and key and value. So for apple, it prints its value 1, and for orange it prints its value 3. Moving on, we are creating a data frame and now we will extract the element from our data frame. So as soon as I print this data frame and create this data frame, I have now accessing the column name, so it will print all the names inside the name column. Same goes for age. So if we change with this age, so it will show all the values of age columns. Next we have LOC. LOC is used to extract and specific elements from a data frame. So we have defined data frame dot LOC and we are passing 1 and it will get the first raw and it will print the first raw. Like for example, for name it's name is Bob, and then age is 30, and then city is San Francisco. So the first element is Alice, and the next second element is Bob, and then third element is Charlie. So at index 1 we have got Bob, at index 2 we have got Charlie. Moving on, we can also define and get the specific elements on based on indexes. So here we are passing 0 till 2. So till uh, second index element will not be, or sorry, the third element, which is Charlie, will not be here. So it will only show the first two values, which is 0 and 1. So that's how you extract the element using from a data frame. Next, we have defined a NumPy array, and now we are defining a conditional statement called myArray is greater than 2. So it will print 3, 4, 5 in form of a list. So you see, it didn't print the 1, 2 because it was not satisfying this condition. And if we do this, it will only show 1 because it's less than 2. Same, we can play around with it. Next, we have to define a we are defining or we are updating our data frame, and here we have got a name column and we are changing the index. So by default it was the simple 0, 1, 2. Now we are changing and we are defining name as the index. So we will call set index column from pandas and we will define this. So now we have indexes as name and age and city as two columns. Now if we do this, like print for Bob, so it will make sure that it will only print the age and city columns and name as index, and name will be Bob. So to go back to the original state of the data frame, we can simply reset the index and print the data frame, and it will be it will be the same as we define it. In the end, we are defining the same thing, but this time this data frame, first we are defining this and then we are changing the index to name, and then we are extracting the element based on .loc function of pandas. So it will get the Bob columns, like the values of the Bob like age and city, and it will print as it is and using .loc function. We can also define multiple indexes, and what column we needed we can also define through in this loc function. So here we are defining first to get the indexes of Alice and Charlie, and get only the age column associated with these indexes. So it will print name and with their ages. So that's how you play around with indexes in NumPy and Pandas library. So that's all for today. Remember, Python indexing is a fundamental concept that unlocks the power of data access and manipulation across various data structures. From lists and strings to NumPy arrays, dictionary, pandas, data frame, indexing provides developers with the ability to efficiently retrieve specific data and elements for analysis. Python programmers can tackle data related challenges effectively, optimize code performance, and explore the endless possibilities of data manipulation using indexes. That's it for today. Don't forget to like and subscribe my channel and hit the bell icon. Take care. Goodbye.